Every motorcycle has a story. Some are legends of reliability, serving their riders for decades. Others, well, they're legends for all the wrong reasons. These aren't just mechanical failures, they're cautionary tales of engineering gone wrong. From Italian exotics to American classics, here are the 10 motorcycles that left their owners stranded, broke, and questioning their life choices. The 1980 Harley-Davidson Sportster 1000 marked a dark chapter in Milwaukee's history. Under AMF management, quality control plummeted to new lows. The starter motor became the bike's Achilles heel, failing so frequently that dealers started keeping extras in stock. With no kickstart backup system, riders resorted to bump starting their bikes in parking lots and on hillsides. The electrical system suffered from notorious voltage regulator failures, leaving riders stranded with dead batteries. The engine's excessive vibration wasn't just uncomfortable, it literally shook parts loose. Bolts needed constant retightening, and electrical connections deteriorated faster than a paper bag in rain. The charging system frequently failed due to poor connections and substandard components, leading to complete electrical system shutdowns. Even the paint quality suffered, with chrome parts rusting prematurely and finishing flaking off after minimal exposure to weather. The carburetor required constant adjustment due to vibration-induced problems, and fuel system components deteriorated rapidly. KTM's 2018 Duke 790 arrived with tremendous fanfare, but quickly became a lesson in first-generation problems. The 799cc parallel twin engine showed serious issues with oil seepage around the cylinder head gaskets. Coolant leaks from improperly sealed water pumps led to frequent overheating episodes, especially in urban traffic. The sophisticated ride-by-wire throttle system developed random glitches, causing unexpected stalling at stoplights. Owners reported transmission problems, with some bikes jumping out of second gear under acceleration. The electrical system proved particularly troublesome, with dashboard displays failing and error codes becoming a regular occurrence. KTM dealers struggled to diagnose problems due to complex electronic systems, leading to extended downtime for owners. The fuel injection system suffered from mapping issues that caused rough running and poor fuel economy. Quick shifter problems led to missed shifts and potential transmission damage. The ABS system would occasionally deactivate without warning, catching riders off guard in critical moments. The side stand sensor frequently malfunctioned, preventing the bike from starting or causing it to stall unexpectedly. Want more motorcycle content that cuts through the marketing hype? Hit subscribe. We're just getting started with these mechanical mishaps. The 1986 Ducati Passo 750 stands as a testament to form over function. Its Weber carburetor, an automotive-derived unit, proved completely unsuitable for motorcycle use. At low speeds, fuel pooled in the float bowls, causing frequent flooding and stalling. The enclosed fairing design trapped engine heat like a pressure cooker, pushing operating temperatures dangerously high. The cooling system struggled to cope, leading to frequent overheating in traffic. The electrical system used numerous ground connections that corroded easily, causing intermittent failures of everything from lights to ignition. Even simple maintenance required extensive fairing removal, turning basic tasks into time-consuming ordeals. The fuel tank's shape restricted capacity while making refueling difficult. The unique square headlight used proprietary bulbs that were expensive and hard to find. The Weber carburetor's complex linkage system required frequent adjustment and specialized knowledge to maintain. Valve adjustments needed precise shim calculations, and accessing the valves meant removing multiple body panels. Yamaha's Virago XV535 from 1981 to 1983 became infamous for its electrical gremlins. The charging system used a stator design prone to early failure, often burning out before 10,000 miles. The voltage regulator/rectifier unit mounted directly above the rear cylinder, where heat exposure shortened its lifespan dramatically. Carburetor problems plagued the model, with vacuum diaphragms failing regularly and sync adjustments needed frequently. The starter system used a complicated reduction gear that wore prematurely, leading to grinding noises and eventual failure. Frame design issues caused the engine to act as a stressed member, transferring excessive vibration to the handlebars and foot pegs. The starter clutch would often fail, resulting in a freewheeling starter motor that wouldn't engage the engine. The camshaft chain tensioner design was prone to failure, leading to timing issues and potential engine damage. Fuel petcocks would leak or fail entirely, causing either fuel starvation or dangerous pooling of gasoline. The ignition pickup coils frequently failed due to heat exposure, causing no-start conditions without warning. The 1997 Suzuki TL1000S packed a 996cc V-twin engine that produced brutal power, but its innovative rear suspension became its downfall. The rotary damper system used temperature-sensitive hydraulic fluid that broke down under sustained use. High-speed cornering became unpredictable as the damper lost effectiveness, leading to dangerous handling characteristics. The engine's aggressive power delivery combined with the suspension issues created a perfect storm of instability. The cooling system struggled with the V-twin configuration, refrigeration, causing frequent overheating in the rear cylinder. The fuel injection system suffered from sensitivity to electrical interference, causing random stuttering and power loss. The frame geometry proved unstable under heavy acceleration, leading to notorious tank slapper incidents. The clutch basket would wear prematurely, causing notchy gear changes and difficulty finding neutral. The charging system struggled to keep up with electrical demands, leading to battery drain issues. The rear brake design is prone to overheating and warping during aggressive riding. Even the fuel tank's internal coating would deteriorate, clogging fuel filters and injectors. Bimota's 1995 500 V2 represented ambitious engineering without proper development. The fuel-injected two-stroke engine required precise calibration that few mechanics could provide. The injection system's sensors proved highly sensitive to temperature and moisture, leading to frequent failures. The engine's power delivery was inconsistent, with flat spots throughout the rev range. The cooling system struggled to maintain stable temperatures, and the complex electronic control unit often failed to compensate for changing conditions. Parts availability became nearly non-existent, leaving owners with expensive paperweights when components failed. The carbon fiber components would delaminate from heat exposure, requiring expensive replacement. The unique engine management system required specialized diagnostic equipment that most shops didn't possess. The expansion chamber design led to power valve issues and expensive repairs. The transmission suffered from weak output shaft bearings that could fail without warning. Think these bikes are bad? Wait until you see the top 4. They make these look like reliable daily drivers. The early 2000s Harley-Davidson Softail Deluxe featured a cam chain tensioner system that became a ticking time bomb. The plastic shoes wore down rapidly, spreading debris throughout the engine oil. Chain tension would suddenly fail, causing catastrophic engine damage. The problem typically surfaced between 20,000 and 30,000 miles, just outside warranty coverage. The only reliable fix cost thousands of dollars, requiring a complete conversion to a gear-driven cam system. Oil consumption increased as the tensioners wore, leading to additional engine stress and potential failure. The compensator sprocket would wear prematurely, causing chain noise and potential failure. The oil pump drive gear could strip, leading to sudden loss of oil pressure. Even the transmission main shaft bearings were prone to premature wear, causing shifting problems and eventual failure. The exhaust bracket design led to cracking and expensive repairs. Norton's 1990 F1 Sport attempted to bring rotary engine technology to mainstream motorcycling. The results were disastrous. The engine's apex seals required replacement every 15,000 miles, an engine-out service operation. Oil consumption reached nearly a quart every 1,000 miles. The sophisticated fuel injection system proved impossible to keep properly tuned, leading to rough running and poor fuel economy. The cooling system barely managed to keep temperatures in check, and the exhaust system deteriorated rapidly from the intense heat. Finding qualified technicians became nearly impossible, as the rotary engine required specialized knowledge few possessed. The unique engine design meant that even basic maintenance procedures required extensive disassembly. Heat management proved problematic, with cases of melted side panels and scorched riders' legs. The electrical system suffered from heat-related failures, particularly in the CDI unit. Replacement parts became increasingly rare, forcing owners to fabricate solutions or park their bikes permanently. BMW's 2010-2014 S1000RR first generation came with serious engineering oversights. The connecting rods could fail catastrophically, sending parts through the engine cases. The gearbox suffered from shift fork failures, leaving riders stranded in gear. The ABS system's control unit frequently failed, requiring expensive replacement. Engine management sensors proved unreliable, triggering false warning lights and limiting performance. The quick shifter system often malfunctioned, causing missed shifts and potential transmission damage. The dashboard displays suffered from pixel failures, making critical information unreadable. The cam chain tensioner design was prone to failure, leading to valve timing issues. The throttle position sensor would fail intermittently, causing erratic power delivery. The stator could fail without warning, leaving riders stranded with dead batteries. Even the factory stand mounts were prone to cracking, requiring frame repairs. The 2000 to 2005 MV Agusta F4 represents the peak of beautiful but unreliable Italian engineering. The engine's complex valve adjustment procedure required specialized tools and expert knowledge. Electrical systems failed regularly, with stator and regulator rectifier units lasting mere thousands of miles. The fuel injection system suffered from numerous sensor failures, causing poor running and starting issues. Cooling system components leaked frequently, leading to overheating and potential engine damage. The transmission suffered from weak shift drums that could crack without warning. Parts orders from Italy often took months to fulfill, leaving bikes parked for extended periods. The electrical connectors corroded easily, causing intermittent failures throughout the bike. The cam chain tensioner design was problematic, leading to expensive top-end repairs. The sophisticated engine management system was prone to failure, requiring expensive module replacement. Even routine maintenance procedures became nightmarish exercises in patience and wallet-emptying expenses. These bikes remind us that innovation without reliability is just an expensive disappointment. Some became collector's items, others became cautionary tales, but they all left their mark on motorcycle history, often in the form of oil stains on garage floors.